Hi guys, in this video we're going to talk about acid-base conjugates and we're going to try to identify some of those. The first thing we're going to start off with is remembering what a Bronsted-Lowry acid and base is. Now, we had two definitions that we looked at. We also looked at the Arrhenius acid base, and remember Arrhenius says that you take an acid and a base and you end up with a salt and water. But that only accounts for some of the acid-base reactions, and the Bronsted-Lowry acid-base accounts for more of them because not everything has the OH in it that's a base, and not all the acids behave the same way. So this is an insufficient way to think about it. So what we do then instead is look at our Bronsted-Lowry acid and base. Now remember, the acid is the proton donor. That means that it gives up the H plus. The H plus, in order to have that positive charge, just lost its electron, so it's really just a proton sitting around in there. And then the base is the opposite. It's the proton acceptor. Okay, so this one gains that H plus. Okay, so really we're just exchanging that H plus. So when we identify these, what we end up with in an acid-base reaction for a Bronsted-Lowry is the acid gives up the electron and becomes the conjugate base. And the base gives up or accepts the electron and becomes the conjugate acid. What this means is that if you run it the other way, that base, this acid that lost the proton, can get it back, and so they become a pair. So this is the acid-base pair. And this one becomes the acid-base pair also. You'll be asked to identify those in some quizzes and in homework questions to identify the pairs, and it's pretty easy. You just have to decide whether or not the difference between it is a proton. So if it can gain or lose a proton, then if one has it with a proton and one has it without the proton, then you'll see it there. So let's look at a few of these. We'll start with some easy ones. Okay. So here we have H2SO4 and H2O, and we're making H3O and HSO4 minus. Okay, so what's happening here, you can see the combos here. Here, these two go together, so I'm going to go ahead and mark them as together, and these two go together. Okay, and in this situation, this guy had the proton and this guy lost it. So this was the acid because it donated one of those H's. Okay, and this then becomes the conjugate base, which we'll talk about again in a second. Okay, and here this water gains the proton, so this is your base because it accepted that hydrogen, and so this becomes your conjugate acid. Now, to understand why we call this an acid, you have to look at what if we went the other way. So what if we went this way instead? Okay, my HSO4 is gaining the proton, it's accepting it, so that's why I wrote base here, because it's accepting. Oh, you can't see that up there. It's accepting the proton, so it becomes the base in the reverse reaction. Okay, so a question you can ask yourself about the conjugates. Whoops, I switched my letters there. There we go. Conjugates. What if it were reversed? What if it were reversed? And if you think about what would happen to that proton, which way would it go in that situation, that will help you identify whether it's an acid or a base. But remember, your acid has a conjugate base and your base has a conjugate acid. That's how they go together. Okay, so then you would say that H2SO4 and HSO4 minus is an acid and a conjugate base pair. Okay, so that's kind of what we're talking about here. So let's look at another one. I want you to first see the difference between these two. Do you see how there's one arrow here and two arrows here? H2SO4, remember, is one of those strong acids. And as a result of those strong acid, it completely dissociates in water. HC2H3O2 is a weak acid, and so it doesn't completely dissociate. So what we do is we write that the arrows go both ways. So that's how we know that it's a weak acid. Okay, so let's identify these. So here's my HC2H3O2, and there's the match there, and then these guys are here again. And notice that this one donated, and this one it gave it up. This is after it donates, and this one accepted. And so this is my base, and this is my conjugate acid. Conjugate acid. In the reverse, this H3O accepts, or I'm sorry, it donates a hydrogen, and so it becomes the acid. And in this situation, it goes the other way. So this one is my acid, and this is my conjugate base. Whoops, conjugate base. Okay, so it might help to think about it one way or the other, but we're still looking at the base pairs there. Okay, let's look at some that aren't quite so obvious, because this one makes some sense here with the H2O and seeing what's going on with the H right in front there, that it's obvious that it's an acid. Let's take a look at this one. This one's not quite so obvious, but we're still going to follow the same idea here. Our acid, remember, has to donate, and our base has to accept. And then I forgot a little arrow point right there, huh? And then the conjugate acid and the conjugate base would be the difference there. So if you can see here, this one might be a little bit easier. Here we've got our acceptors there, or what's going on there, and then here's our other pair here. Okay, so my NH4, it actually has an extra H here and a plus charge, so this one has gained. So this one here is my base, and this is my conjugate acid. I am switching up the letters there. It's really annoying. Okay. My water molecule actually lost a hydrogen this time, so it donated. Okay, and here we accepted. So this one is my acid. In this situation, the water is acting as my acid, and the last two that we looked at, the water was acting as the base. Remember, we call that amphoretic when it can go either way. This acid has a conjugate base pair over here, conjugate base, that going the other way would gain the hydrogen from the NH4. Okay, so that's another weak base because it goes both ways. Or that's a weak one when it goes both ways like that. Okay, this last one here, notice how it doesn't have any water in it. So this one might be even harder to think about, but again, we're still looking for the pairs. So here's my F's. So there's a pair right there, and here's a pair right here. Okay, so this one hopefully is kind of obvious that this hydrogen used to have that be stuck to the F, and now it's not. So this one must have donated. And then this one, you can see that it gained an H, so this one did our accepting. The donated one is the acid. The accepting one is the base. Okay, our acid has a conjugate base, and our base has a conjugate acid. So we're really just labeling things, and it's a lot easier when you can see the whole equation. But if you were just given a pair, you really need to ask yourself, is the difference between these two things an extra hydrogen? Is the difference between these two things an extra hydrogen? If it is, then you would say that it's a conjugate acid-base pair. Okay. If you have any questions, make sure you ask your teacher. Try those practice problems in your homework. Thanks for watching.